Hi everyone, welcome back to the session. So in this session, we'll see how to backtest value at risk. See, we up till now what we saw was what are different ways to model value at risk, which is in particular modeling value at risk using the variance covariance method. Then we saw historical method, and then we saw Monte Carlo method, right? And if you have not seen the previous videos on value at risk using these three methods, I highly suggest you to look into those. So these are different modeling techniques or modeling methods for value at risk. So typically these three were the different methods. Now the idea is to understand how can we backtest value at risk. Okay. So what I'll be covering is two different techniques, which is the traffic light approach. And this technique is actually used by regulators. These are advised by regulators, and these are actually used by financial institutions, and it is also mentioned in the Basel documents. Okay, so Basel is again, regulatory document in which the regulators have asked the financial institution to backtest value at risk using the traffic light approach. And then we have something called the Kupic method. Now, Kupic is nothing but a statistical method for backtesting value at risk. So we'll see these two methods of how of backtesting value at risk. But in this video, we'll focus on traffic light approach. Okay. So let me first tell you, why do we do backtesting? Even before going deep into the value at risk, going deep into the traffic light approach for value at risk, let's first understand why do we even perform backtesting. So, so let's see backtesting value at risk. Okay. So see, the main reason or the reason why we backtest value at risk is because we need to evaluate the accuracy and the effectiveness of the value at risk models, or you can say of the or you can say that we need to evaluate the accuracy and effectiveness of the value at risk number that we have calculated using the three models, right? So backtesting is nothing but it is a technique. So backtesting is a technique used to evaluate the accuracy and effectiveness of the value at risk number. And now, how is this value at risk number calculated? Using different value at risk models. Okay, okay, perfect. So now the question is, okay, let me, deep dive into further. But just remember, backtesting is a technique used to evaluate the accuracy and effectiveness of value at risk number. Now, to clarify it further, just think this in this way, that backtesting is like doing a practice test before going for the real exam. Okay, so just imagine this in something like this, that backtesting backtesting is like doing a practice test before you go for the real exam. So what does this mean? This basically means that we are we are we are using backtesting, or we can say that we are just checking if the value at risk number that we have calculated actually works well with the real life situation. Okay. So, what we are essentially trying to check is if the methods for predicting or whatever value at risk number that we have calculated actually works well with the real life situation. And just imagine, why do we want that? See, if in case our value at risk number is not accurate, if it's not accurate, right? Of course, what will happen? What are the consequences? Definitely, if your value at risk number is not accurate, that basically means that your portfolio might face a higher loss than what was expected. And no one would want that, right? No one would want that, right? So that's why we want that our value at risk number should be accurate. And how do we make sure if it's accurate or not? By backtesting. So just to summarize, or just just want to highlight the reasons, or in simple terms, why we are backtesting. So the first reason is to test for accuracy. Okay. So what it basically means is we use backtesting to make sure that the model prediction about the potential financial losses are accurate. If the model predicts you could lose up to $100,000, backtesting helps verify whether such prediction holds true based on the past data. Okay, so we use backtesting, just writing what I said. We use backtesting to make sure that the model's prediction about the potential financial loss are accurate. Okay. If a model predicts that you could lose, let's say, $100,000, right? If the model predicts that you can lose $100,000, backtesting backtesting helps you to verify whether such prediction holds true or not. Whether such prediction holds true based on past data. Okay, so let me highlight the important things. So basically, we are backtesting just to test for accuracy. So we use backtesting to make sure that the model prediction about the potential financial loss are accurate. See, if a model predicts that you could lose up to $100,000, right? Backtesting, what it does, it helps you verify whether such prediction, what is the prediction that you can lose $100,000. So backtesting helps you verify that this prediction holds true or not based on the past data. See, when we'll do the Excel implementation, it will be very, very, simple to understand the backtesting piece. But this is before going to the Excel, I really want you to make you understand the theoretical piece. So, second thing is, so this was the first reason. Second reason why we do backtesting is so as to improve the models. So basically, if the backtesting, if backtesting ratio or if backtesting of the model shows that the model is often wrong, right? Then what will happen? Basically, it means that the model needs improvement. So we need to adjust the model so that it can tell us, or it can help us understand what will be the future losses, right? So so basically, if backtesting if backtesting shows that the model often gets wrong, okay? So let's say your model predicted that the value at risk number is $10,000, which means that your portfolio can face $10,000 of loss, right? Now, what is happening is in actual, you are actually facing a loss greater than $10,000, and this is happening very frequently. This case is happening very frequently, right? So then you know that basically when you perform backtesting, it will show that the model of is often getting wrong, right? And again, this is based on past data. Okay, so you will perform the backtesting based. See, always remember, backtesting will always happen based on past data. We will never use future data. Okay, we'll always use the past data to perform backtesting. Okay. So of course, I mean, if the backtesting results aren't great, then we know that for sure that we need to improve our model, right? And the last reason why we do backtesting is to comply with the rules. What it basically means is, see, regulators, regulators in general, they require financial institution to backtest their model. Okay. So regulators in general require all the financial institution to backtest their model. Okay. And why do regulators need this? So as to ensure that the models are robust and the institutions are not underestimating their risk. So this is to ensure that models are robust and institutions are not underestimating their risk. Underestimating the risk. See, there are a couple of reasons, but these are the main reasons why we do backtesting. So just to summarize, the first reason is to, of course, test for accuracy, right? To test if whatever value at risk number that we have calculated, if that is accurate or not. That's the first reason. The second reason is to improve the model. And the last reason is to comply with the regulatory requirements. Okay. So these are several reasons why we perform backtesting. Okay. Now, is there any questions that you have up till now? Okay. If there are no questions, let me go through the first backtesting. Let me go through the first backtesting method, which is traffic light approach. Traffic light approach. And this is the approach which is recommended by the regulators. Okay. This is the backtesting approach which is recommended by the regulators. Okay. So let's understand what is this approach. See, the traffic light approach for value at risk, it is nothing but it is a method which is used to assess the risk level of an investment or a trading position using color coded signals. Okay. So just see this word traffic light. Tell me one thing. We all have seen traffic light, right? So you will see something like this, you know. They will be three, in any country you go, I think traffic light is like the same, You have this here, you have the red color, then you have, the yellow color, and then you have the green color, right? Okay, I'm not able to find yellow, but just imagine we have a yellow color, okay? Let's see, this is a yellow color, okay? So traffic signal wherever you go, this is how the convention looks like. You have the red color, you have the yellow color, and then you have the green color. And see, based on this only, regulators have by using the colors, they are trying to tell you something about the risk. Okay, by using the color. Okay, so let me write it properly. Let me give you a proper definition. Okay, so the traffic light approach is a method. Okay, so the traffic light approach is a method used to assess the risk level of investments. Okay, using color coded signals. Okay, using color coded signals. And what are those signals? There are three signals: red, yellow, and green. Okay, so this, okay, so the traffic light approach is a method used to assess the risk level. Okay, so it will help you understand what is the risk level of your investment based on these three colors: red, yellow, and green. Okay, so let's understand this in more detail. So, this approach helps financial institutions. Okay, this approach helps financial institutions and risk managers quickly understand the risk exposure and decide on necessary actions. See, like in even in the industry, everyone is using traffic light approach. So this is actually from an industry standpoint, the traffic light approach is very important for understanding how can we backtest our value at risk models. Okay, and of course, this approach helps financial institutions, risk managers to understand, okay, what is the risk exposure. See, based on these colors, red color, yellow color, green color, they can understand what's the level of the risk. Is it a low risk, is it a moderate risk, or is it a high risk? And once they understand what is the risk level, then they accordingly take necessary actions to mitigate those risks. Okay, so here is how, let me make you all let me write this. Here is how traffic light approach is applied to value at risk. Okay, so let me tell you how can we apply traffic light approach to value at risk. Okay, so as I said, you know, what will happen is you have this value at risk number. Let's say this is $10,000. Okay, this is your value at risk number. So now what will happen is, let's say now you take last 250 days of data. Let's say you take last 250 days of data, right? So so this is again, always remember, we will always consider past data, past 1 year data. Okay, so what will happen is for each day, you will check how much is the losses. You will check how much. Okay. So the first thing is check for, okay, consider 250 days of trading data. Okay. So we'll consider 250 days of data. Okay. Second thing is check if if the losses are greater than value at risk number. Example for this is, let's say your value at risk number is $10,000. So every day you need to check if your portfolio loss is less than or greater than $10,000. Okay, you need to check this every day. Let's say, let's say if the loss is greater than $10,000, so then you will say this as a breach. You will say this as a breach, or you can say violation. Okay, so if your loss for any given day, okay, for any given day, if your loss is greater than $10,000, what is this $10,000? This is a value at risk number. This can change. This can be $5,000, $20,000 based on what your model has given out. Okay, what your value at risk model has given out. So you just need to check in the last 250 days. In the last 250 days has for any given day, was there a day in which the loss was greater than $10,000? If there were days, just mark those days as breach or violation. Okay. The next step is count the total number of days of breaches. Okay. Count the total number of days or count the total number of breaches. Okay. Okay. So let's say if, and once you count the total number of days or total number of breaches, classify it into color color signals. Okay, so what it means is, if it's a if the breach is between 0 to 4, this means it's in green zone. The model is in green zone. If the breach is between 5 to 9, the model is in yellow zone. And if the breach is greater than 10, the model is in red zone. So what does this mean? This basically means is, if your breach is between 0 to 4 days, basically for there, there are like zero between 0 to 4 days wherein your loss was greater than your value at risk number. Okay, your loss was greater than value at risk number, it will be considered as green zone. Similarly similarly if your breach, or if the total number of days is between 5 to 9, it will be considered as yellow zone. And if the breach, or you can say, what is a breach? Always remember, what is the breach? Breach is nothing but if the loss is greater than value at risk number. Okay, this 10,000 is just for example. This is nothing but value at risk number. This can be 20,000, 30,000, or whatsoever. Okay, so if the breach is greater than 10, it will be in a red zone. Okay, so now, so what does this zone implies? Okay, so, okay, first of all, did you all understand this? What is a traffic light approach? It is nothing but What is a traffic light approach? It is nothing but it is a method which is used to understand the risk level of investments. Okay. And how will you understand? Based on the coded signals. Okay. Based on the coded signals. Now, how will you give a signal? How will you give a color signal? So basically consider last 250 days of trading data. Check if the losses are greater than value at risk number. If the losses are greater than the value at risk number, then it is considered as breach. And then you count the total number of breaches. And based if the breach is between 0 to 4, it is called green zone. If the breach is between 5 to 9, it is called yellow zone. And if the breach is greater than 10, then it is called red zone. So now let's see what is green zone, yellow zone, and red zone in detail. So let's see what is green zone. So green zone is nothing but the range of breaches. First of all, the range of breaches between 0, 0 to 4. Then what are the implication of this? Implication is nothing but we can say that here. So green zone is also called low risk zone. Okay. So basically what is the implication? Implication is that the risk levels are low. So the risk levels are low, and the frequency of exception or the frequency of breaches is within the expected range. What is the expected range? It is nothing but 0 to 4. Okay. Suggesting that the model is performing well. Model is performing well and is within acceptable limits. And is within acceptable limits. Okay. So always remember, what does green zone mean? It basically implies that the risk levels are low and the frequency of breaches is within the expected range. What is the expected range? 0 to 4. So when the breaches are low, or we can say they are within the range, expected range, it basically means that the model is performing well, and the exposure, or you can say the number of breaches is within the acceptable limit. So it means that, okay, you are good to go. You don't need to worry about the model. Okay. So now what is the action item? What is the action item? The action is nothing but normal monitoring and operation can continue without immediate concern. So normal monitoring and operations can continue without immediate concerns. So this was all about the green zone. Okay. So always remember, if your model, just to summarize, if your model is in green zone, the number of breaches are between 0 to 4, should be between 0 to 4. If your number of breaches are between 0 to 4, it will be in green zone. And then it basically means that, what does this mean? What does the green zone means? That your model is good to go. Okay, you don't need to worry about the model. You just need to monitor it, and you do not need to take any actions on the model. And also basically here risk levels are low. Okay. So this is what it means by green zone. Now let's see yellow zone. And guys, once I explain you this, we'll also see Excel implementation so that is easy for all of you to understand. Yellow zone. So what is yellow zone? See, yellow zone is also called moderate risk. Okay, yellow zone is also called moderate risk. What is the range here? So range is between 5 to 9. So for green zone it was 0 to 4, here it is 5 to 9. Then we have, what are the implications? So risk level are moderate here. So the risk levels are moderate. Okay. So basically, what it means is the frequency of exception is higher and nearing upper tolerance limit. The risk level. So basically, the risk level are moderate, and then the frequency of breaches is higher and nearing the upper tolerance, indicating that model might not be able to capture some risk effectively. Okay, just think, if you see what we are trying to say. See, we are saying that okay, yellow zone is a moderate risk. When will someone give a yellow zone to a model? They will only give when the breaches are between 5 to 9. So if you see in the green zone, the breaches were between 0 to 4. Now here the breaches are increasing. What it is basically saying is now we are seeing five breaches between 5 to 9 breaches. And what is the breach? Breach is nothing but that your daily loss is actually exceeding your value at risk loss, right? And whenever something like that happens, that's actually a breach. So when breaches are happening regularly, let's say 5 to 9 times, that's actually a concern, right? Because you are facing more losses than what you expected. And that's why we say that your model might not be able to capture some risk effectively. Okay. That's why we say that the model is not able to capture the risk effectively. So now what is the action item here? What is the action item? See, the action item is nothing but you need to increase the scrutiny here, increase the scrutiny of your portfolio, and review the portfolio. So increase to scrutiny on your portfolio and review the portfolio's strategy and perform on. See, what I'm trying to say here is, see, when something like this happens, what you have to do is, or what a financial institution does is basically they increase the scrutiny. What do I mean by increasing the scrutiny is basically they will review the portfolio every day. So, see, something like, when you are facing losses more often, of course, it is for sure that you will see like which part of the portfolio is giving you more loss. Sometimes all the stocks or in your portfolio is giving you loss. Some stocks are giving you loss, so you need to identify and need to perform daily monitoring. Okay. And see, the question is, okay, once we have identified, what's the next step, right? Once we have identified that, let's say out of 10 stocks, two stocks are actually creating issue, because of only two stocks, we are facing losses in our portfolio. Then the action item is either sell those off, because because of that too you are facing the losses, or you need to basically create a strategy that even though the prices declined, you are not facing loss in your portfolio. So there should be some strategy which balances that out. Okay. So just make sure when you have a yellow zone, it basically means you are in a moderate risk level zone, and that basically means when do you give a yellow color to the model? When the breaches are between 5 to 9, which basically means that between 5 to 9 days we actually saw that the losses were greater than value at risk number. Okay, and you need to make sure you need to increase the scrutiny of the portfolio. Now the last is your red zone. Okay, your last piece is red zone, which is a high risk zone. Okay, Red zone is nothing but a high risk zone. Okay. So what do I mean by high risk? Here, what is the range? So range is greater than 10. Greater than 10. Basically, what I'm trying to say here is in last 1 year, last 250 days, we actually saw that for almost 10, for greater than 10 means 11 days. Okay. For almost, okay. So here we have five, yeah. So for almost 11 days, we actually saw that there were losses which were greater than the value at risk number. Okay. So here the risk levels are high with a significant frequency of ec- breaches, suggesting the model is inaccurate or there are severe risk management issues. Okay. So what are the implications here? Here basically risk levels are high. Okay. Risk levels are high with a significant frequency of exception. Okay. Suggesting that the model is suggesting the model is suggesting the model is inaccurate or there are severe risk management issues. See, just imagine that when you are seeing that the losses are happening more often in your portfolio, and it is not just happening more often, it is, your losses are greater than the value at risk number. That's what we say as breach, right? So what does that mean? It means that your risk levels are high with a significant frequency of exceptions, or you can say significant frequency of breaches. Okay, both means the same. Okay, with a significant frequency of breaches, that your breaches are happening again and again, suggesting that the model is inaccurate or that there are severe risk management issues. See, it's very simple that when more losses are happening in your portfolio, something is wrong. And if there are more losses happening in your portfolio, the first question is why the model was not able to capture it, right? Because now what you will say is the model was inadequate, right? Or the other thing you will say is, or there are severe risk management issues. That's why we were not able to predict the we were not able to predict the losses, and that's why now we see more number of breaches happening in our portfolio. Okay, so this was all about the green zone, yellow zone, and red zone. Just a quick summary, right? So we have three zones. We have green zone, we have yellow zone, and we have red zone. For green zone, we have low level of risk. Here we have moderate level of risk. Here we have high level of risk. Okay, then here we have what are the breaches allowed, 0 to 4. Here we have 5 to 9, and here we have greater than 10. Okay, these are your breaches. So if you see three breaches, if you see three breaches in your portfolio, you will assign which zone? Green zone, right? But what when I say three breaches, it basically means that for 3 days in last 1 year, you saw losses greater than value at risk number. This is what we say as breach. Okay. So guys, this was all about the traffic light approach. Now let me walk you through the Excel implementation really quick. So let me share my screen quickly. Just give me 1 second, guys. Let me share the screen. Okay. Yeah. Can you give me a heads up if if you can see the screen or not? Can you give me a heads up if you can see the screen or not? Just give me a heads up if you can see the screen or not. Yeah, still waiting for all of you. Okay, perfect. Thank you. Thank you for. Okay, so let's see how can we perform. Okay, my bad. How can we perform? Let's see how can we perform the backtesting using the traffic light approach. Okay, so this is a very simple exercise. How can we perform the backtesting? Always remember one thing that of course we have to, when we are backtesting our portfolio, we have to consider our last 1 year of data. Okay, so if you see, I have considered from 8/1/2022 till 8/1/2023. Again, remember that these dates are in the US date format, which is month, day, and year. Okay. So basically, my portfolio, what I'm saying is, in my portfolio, I have three stocks, which is JP Morgan, Morgan Stanley, and Bank of America. So these are the three stocks that I have in my portfolio. Now, the next step is to calculate the returns. So how do I calculate returns? Is simple, that whatever price we have today of the stock divided by whatever price we had yesterday minus 1. Okay. This is the most simplest way to calculate return of the stock, right? So always remember price today divided by price yesterday minus 1. Okay. And then similarly, we'll use the same formula to calculate the returns all over. Okay, to calculate the returns all over. So we'll just use the same formula till the end. Similarly, we'll use the same formula for Morgan Stanley and for Bank of America. So just price today divided by price yesterday minus 1. Similarly, price today divided by price yesterday minus 1. So this is how we basically calculate the returns all over the whatever 1 year horizon we have. Now speaking about the portfolio weights of each stock, right? Basically, it is for sure that we'll have certain weightage of JP Morgan, certain weightage of Morgan Stanley, and certain weightage of Bank of America. So when I say weights, it basically means that I'm investing 30% of my money in JP Morgan, then I'm investing 40% of my money in Morgan Stanley and 30% of my money in Bank of America. So now, so this, if you see this, we calculated individual returns of the stock. Now to calculate the portfolio return, what we'll do is we'll just do some product, right? So what we are saying is, just you can use some product, or what you can do is you can basically multiply W1 with R1. So you can do this calculation. Okay, W1, which is your weights of stock 1 multiplied by return 1, plus W2 times R2 plus W3 times R3. Either you can use this formula, which is multiply weights, the JP Morgan weights with the returns of JP Morgan, add it with the weights of Morgan Stanley multiplied by the returns of Morgan Stanley, and then add it with the weights of Bank of America and multiply with the returns of Bank of America. Either you can use this formula, or you can simply use a sum product. Both will eventually give you the same results. Both will eventually give you the same results. So just do the sum product here, and similarly do a sum product here. Let me show you, just to make you understand, this multiplied by this plus this multiplied by this. Okay, sorry, this multiplied by this plus this multiplied by this plus this multiplied by this. So now we got negative of 1.33%, right? And similarly here also we got negative of 33%. So eventually both the formulas are same. It's just the way you want to use it. I like to use some product directly, or you can use this formula directly. W1 R1 plus W2 R2 plus W3 R3. So once we have calculated the portfolio return, right? Sorry, once we have calculated the portfolio return, the next step is to multiply the portfolio return the next step is to multiply the portfolio return with the portfolio value. So if you see, we what did we assume? We assumed that we invested $1 million. If you see, we invested 1 million, or you can say that our portfolio size is $1 million. So if you see, these are our daily returns. So once you multiply the portfolio returns with the $1 million investment, this is how our P&L looks like: profit and loss for daily. Okay, so here if you see, we saw a loss of $13,000. Similarly, the very next day we saw a profit. The very next day we again saw a loss, profit, and so on. Okay, this is how you basically calculate your value at risk of the portfolio. Okay, this is nothing but value at risk, or this is nothing but your PNL. Okay, let it be, the portfolio value. Okay, this is basically your PNL. Let it keep it like this. Okay, now the question is, how do we backtest value at risk? Okay, the question is, how do we backtest value at risk? Now, to backtest value at risk, what we need to do is, if you all remember the definition of backtesting value at risk, what was the definition? Or let's say, how do we assign that there was a breach or violation? How will we assign it? We will say that if in case the losses is greater than value at risk number, that's where we say it's a breach, right? If the losses is greater than value at risk number, that's where we say that it's a breach, right? So this is our PNL, right? Profit and loss for daily data, right? This is our PNL. Now what we are doing is, we just need to check if this number is greater than value at risk number. So if you have not seen my previous videos in which I've walked through the variance covariance method, historical method, and the Monte Carlo method, I highly recommend you to watch those, because in that I have basically told how do we calculate these three numbers. Okay, what you see on the screen. So I basically told how we calculate value at risk using the variance covariance method. So what we basically got was these three numbers from these three different methods. Okay, so let's see and these all are value at risk number. Okay, these all are value at risk number. So what we essentially need to check is, we just need to make sure, like, okay, this is a VaR number, right? So we will be doing testing for all the three methods. So we'll backtest all the three methods, which is the variance covariance method, the Monte Carlo method, and the historical method. So what we are checking is, if in case the our PNL or profit and loss, if is it greater than the value at risk number, so we'll use this formula all over, right? We'll use this formula all over, right? So if you see, what is happening is, only this is if only this number is being dragged down, but the x4, which is your value at risk number, is being constant. If you see, this number will always remain constant. Okay, so what we are checking is, if the value at risk is it, or let's say what we are checking is the loss, what we see is that greater than the value at risk number or not. Okay, and accordingly we are assigning yes or no. Accordingly we are assigning yes or no. So we see value at risk number, is it greater than R4 or not? Okay, is it greater than R4 or not? Oh yeah, okay, I guess sorry, I did a mistake. I guess I think we need to make sure if the actual loss, if is this greater than the value at risk number. Okay, and if this is the case, okay, 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 I think there is one thing that I'm missing out. Just give me 1 second. Okay, so we are checking that if the daily loss, if this, okay, oh my bad. So always remember, because if you see this law, when things goes in negative, the direction actually becomes reverse, right? If you see that when things goes negative, see, let's say -5 and -3, right? Let's say -20. -5 and -20. It always, in numbers, we always assume that -5 is greater than -20, right? We always assume that -5 is greater than -20, right? If you see this case, -5 is greater than -20, and same if we keep -3, it is still the case that -3 is greater than -20. But always remember this thing that, see, what we are trying to achieve is we are trying to check if the losses are greater or not. I mean, if the losses are greater, just think, in the if we just take the absolute values, right? I mean either I can reverse the direction here and take absolute values, but I have not taken absolute values. So I've just reversed the direction. Okay. So what I'm saying is, okay, tell me one thing. Is $13,000 of loss, is it less or is it greater than $35,000 of loss? It is of course less, right? And that's why if you see, if the loss is less than the value at risk number, that's where there is no breach, and that's why I have written false. Okay, guys, I hope you understand. Okay, I hope you understand. What I have done is, right now you might be seeing, okay, I've used the reverse direction, but essentially what I'm doing is, what I'm checking is, okay, is $13,000 loss higher or lower than the 35,000? Of course, it's lower, right? Of course, it is lower, right? So when the loss is lower than the value at risk number, there is no breach. Okay, there's no breach. But let's take certain example in which we saw a breach. Let's see this example. $50,000 loss, right? So is $50,000 loss higher or greater than the $35,000 loss? Of course, $50,000 is a higher loss. And that's why when the losses is greater than the value at risk number, there will say that this, yes, the breaches has happened. Okay, that's where we'll say yes, the breach has happened. That's why I'm assigning true. So I hope this is clear. Okay, I hope this is clear. So similarly, so what we'll do is we'll basically check if this number is it, if it's crossing the value at risk limit or not. Similarly, is if this number is crossing the value at risk limit or not. So this will do for variance covariance method. Similarly, when we do for historical method, this series will remain the same. What will eventually same is this number, value address number. Okay. So if you see what I'm checking here is, okay, if the my daily PNL is it is it breaching my value at risk number or not? Of course, $15,000 we have positive. Similarly, there is a loss of $4,000, but our value at risk limit is $36,000. So of course, it is not breaching. Of course, it is not breaching. So that's why we'll we'll do this for till the end, whatever how many data points we have. And similarly, what we'll do is we'll basically check for using the Monte Carlo method also, that is the PNL, right? Or whatever we see daily profit and losses, is it is it breaching the value at risk limit or not? So accordingly we'll put true and false. Okay, accordingly we'll put true and false. But always remember, when we are using the value at risk number, so whenever we are setting the breach threshold, or whenever we are setting the threshold for variance covariance, we'll always use variance covariance method. For historical method, we'll always use this number, value at risk number coming from historical. And for Monte Carlo simulation method, we'll always use the value at risk number that we got from Monte Carlo method. So now the next piece is nothing but we just need to calculate the number of trues. True is nothing but wherever we saw the breach. Okay, if you see these days we saw the breach. Okay, so wherever we saw the breach, we just need to count those days, right? So what we saw was when we just counted. If you see for variance covariance method, we just counted the number of trues in this data series. Similarly, what we did was, in using the historical method, we counted the number of breaches that happened in this whole one last 1 year. And similarly, for Monte Carlo method, we calculated the number of breaches that happened in the last year. And accordingly, if you all remember, what was the limit? If you all remember what we were saying, right? We were saying that if the limit, or if the breaches is between 0 to 4, we'll say that it is in green zone. If the breaches are between 5 to 9, it's between yellow zone. And if the breaches are greater than 10, it is in red zone. So basically, if you see how many breaches did we saw here, in using this number, value at risk number coming from variance covariance, we saw three breaches. Using historical method, we saw two breaches, and using Monte Carlo, we saw three breaches. So in total, we can say that because the breaches for all the models are, it's in green zone. So we can say that, right now the risk of the level, or the risk of the value at risk model is very low. Okay, the risk of the value at risk model is low. Okay, so that's how we basically perform backtesting of our value at risk model using the traffic light approach. So is there any questions up till now? If there are no questions, let me, in the next video, let me walk you through the Kupek method. If you see this Kupek method, let me walk you through this Kupek method, which is also a statistical method of backtesting VaR. But for this video, let me stop the recording, because this is what traffic light approach test is, and that's how you basically backtest your value at risk model using the traffic light approach. So let me stop the recording. Thank you all.